Quickly here, 4.1, okay, sequences, patterns. Just a couple of terms here. Sequence is a list of numbers in a specific order. Specific order is important, okay? When we look at the table here, they use n and f of n. We could relabel this and say our top row are the what values? But what variable? Basic variable, x, okay, and the bottom would be our y, okay? They call it n and f of n, okay? Function notation using a different variable. But what I wanted to point out here was the top has to go in some order, okay? So here our x's or our n's are increasing by 1 each time. So what would go here? That would be 4. This would be 6, okay? Again, we know it's x because here it's labeled domain. So we've got all these different terms that we're using for the same thing in different ways. So we look at our y, our range, our f of n, our y. What is happening here? Going up by 2. So go up by 2 here, that takes us to, this would be 15, okay? Pattern, simple pattern. Now, what is that pattern representing? We said our x's are going up by 1s, our y's are going up by 2. That pattern is nothing more than our slope. So give me a couple of definitions of slope. What do we think about slope? Rate. What else? Okay, but definitions of slope. No, not starting point. Starting point is our what? Y-intercept. What are other definitions we use for slope? Rate, rise over run. There's another one we talked about. Change in y over change in x. Okay? This is the definition we want to use when we talk about a pattern or a sequence here. What's our change in y every time? Nope. 2. Okay, our y's are on the bottom. Change in y is 2. Positive 2 because they're going up by 2. What's our change in x? 1. There's our slope. Now, why is it important to be able to identify that pattern? Because at some point, what is it we're going to have to write? Okay, we are going to graph it, but before we graph it, we have to have the what? The equation. The equation we always use is y equals, there you go, y equals mx plus b. So we have m. Nope. We already have m. We've already gotten m just by looking, okay? Don't make this complicated. This is super easy. Does everybody see where we got the slope? Yes. Okay? Now, what is b? B is the y-intercept. Destiny just said it's also called the starting point. We had other definitions. What were they? The beginning, starting point, y-intercept. Think about the y-intercept. It's where it's on the what? Where it crosses the y-axis. What did we say about every point on the y-axis? What's always the same? If I pick any point on the y-axis, something is always the same. The x-coordinate is always 0, which is why we call it the what term? The zero term. Guys, that's a huge definition to know. Here's how you find the y-intercept. Everybody watching up here says very, very easy. This is term 1. I want to go back and find term 0. What was I doing on the top every time? I was going up by 1. So if I go backwards, what do? I subtract by 1. Everybody good? So to find the 0 term, I do the same thing with the y. I'm not going up by 2. I'm going to go down by 2. What's 7 minus 2? There's your y-intercept. I can write the equation now. Y equals 2x plus 5. I've already got the equation. Why is it important to have the equation? Because I can find anything I want to. Any value. Did everybody follow how to get the equation there?
Yes.
We'll do some more examples here. So it asks some questions here about the values. We could get all of those from the table, and we'll do that later. This is what I want to look at. Identify the domain. Since this is what kind of function again? What do we call this? When we draw it, it's going to make a line, okay? It's going to be a line. Now, when we talk about the domain, remember there are two different types of functions. What are they? What are the two different types of functions we can graph as far as, okay, linear is this particular type, but what are the two different types? There you go, continuous and discrete. What's the difference? Discrete are
Like if you're
individual points, okay? They're separated. Continuous, everything is connected together, okay? So what we have to do is we've got to look at the context of this problem. The total cost of riding a go-kart for different number of laps, okay? Can I have, in other words, can I ride 1 and 1.16 laps?
No.
I either have to do 1 lap or I have to go 2 laps. So is this a continuous or discrete function?
Continuous. No, discrete.
It is discrete. Remember, continuous has every single value in between, which means it has decimals and fractions. Discrete are individual points. These are individual points here. This is a discrete function. Now, it's still going to form what kind of graph? It's still going to form a line. It's just not a line that's what? Connected. So when we talk about the domain, when we talk about the domain of the function, the domain is not all real numbers. We're talking about the number of laps here. So what kind of number of laps can I have?
1, 2, 3, 4, 5.
Okay, so only positive integers.
Yes.
Okay, or whole numbers. Can't have decimals, can't have fractions, can't do a negative number of laps. Everybody understand what I mean?
Yes.
Okay, cost. If I do 0 laps, it costs me how much? $5. So my range is going to be every value that's what? Okay, $5 or more. But how do they go by? They go by, so they go every other dollar or by twos. Okay, so here's where you got to learn to describe these domains and ranges. So it says generating sequences using an explicit rule, okay? What's an explicit rule? All that is coming up with the equation, okay? Coming up with the equation. Now, in this particular example, they've already given you the equation. So how do we find the value of the equation at each of these points? There you go. You go to the calculator. You put the equation under y equals, and then you go to your table set. In this case, you would start at 1. You go by ones, go to the table, look at the values. So here's what I want you to do. I want you to put this one in your calculator. 3n squared plus 1. Take just a minute, go to set your table up, get your values, and write the values in, and then we'll check them. So these are the values you should have written in for that table. 4, 13, 28, and 49. Is that what everybody got on your calculator?
Yes.
Okay.
How would you write the function?
Okay, so quick question. Is this a linear function?
Yes.
Answer is no. If it's a linear, it has a slope. The slope is a rate. More specifically, it's a constant rate of change, which means it does what? Goes up the same amount, constant, the same amount all the time, or it goes down the same amount. Look at my values here in my y. Are they going up by the same amount every time? No. This is not a linear function. Plus, we had the function. It's not linear because my variable is raised to the second power. So, what I want you to do, I'm going to give you a minute here. I want you to try number 6 and 7. Use your calculator, okay? It says find the first 4 terms of the sequence, and then it says find the 15th term. So if I want to know the 15th term, what am I going to do on my table set? Put it on?
15. Well, you go 1 through 15.
You could scroll or put your table set and put your independent on ask. So it makes you ask you what value to put in, and then you would type 15. Okay? So take a minute to do those two. So let's look and see what we've got here. So in the first one, you go to y equals, you type the function in. Remember, you're using x, not n. Go to your table set, put it on. Table start at 1, go by 1. And this one you can do auto because you automatically want it to generate the values for 1, 2, 3, and 4. And you could do ask, but that means you got to type in each one. For problem number 7, this becomes your function, 4x minus 3. This one I did put it on ask because I don't want to scroll down to get to 15. I just put it on ask, I put x is 15, and then it gives you 57. The only way you can get the wrong values for these problems, the only way you can get the wrong value is if you type something in wrong on the calculator. That is the only way. Okay, so real quick, there are 2 different ways to represent functions. The first way we just talked about is what's called an explicit rule. It's the actual equation of the function. Another way to represent is what's known as a recursive rule. Now, there's a major difference here in these. A recursive rule is when you know what the term is and it's telling you what to do to the function itself based on the previous term. Okay, so the notation is this. The term value I'm looking for now is based on what the previous term was. That's why it's n minus 1. So for example, let's say n here is 2. If n is 2, I would put 2 here, and 2 minus 1 is 1. So to find f of 2, I have to know what the value for f of 1 was. Okay. That's all this notation is. Recursive rule means to get the value of the current term, I have to know the value of the previous term. This tells me what I do to it. I'm adding 10. Okay? So if I'm adding the same thing every time, that goes back to like the very first sequence we did. That's a linear sequence. Okay, because a linear has a slope. That means it's going, in this case, it's going up 10 every time. So every time I go over 1, it goes up 10. That's my slope. Now, not every one is a linear, okay? This one is a linear. I'm going up 3 every time. So every time my term number goes up 1, I go up 3. So how does this work? A recursive rule says, okay, if the value of this term is 2, how do I get the next one? I add 3. What's 2 plus 3? 5. Okay. If the value of this one's 5, how do I get the next one? I add 3. What's 5 plus 3? 8. That's how a recursive rule works. Now, you can't plug it in the calculator Because a calculator, you have to have the specific equation. A recursive rule is based on the previous value. So let's look at the example they give us here. We know f of 1 up here is 4. Based on the recursive rule, what am I doing every time? I should be adding 5. Okay? The rule says add 5. So, if this value is 4, what's the next one going to be? 9. Because what do? You have to add 5. What's the next one going to be? 14. Why? Because you add 5. What's the next one going to be? 19. Because what do? You add 5. There you go. So I'm going to do number 10 with you, and then I'm going to let you try number 11 by yourself, okay? So the first thing you need to do, it says find the first 5 terms. Okay, now you can make a table if you want to, like we did before. 1, 2, 3, 4, 5. Now again, you cannot do this using the calculator because you don't have an explicit equation. I just know what's happening each time. F of 1, they tell me, is 35. Now I go look at the recursive rule. What is it that it's saying I'm doing every time? I'm subtracting 2. So, what should I do here? I should subtract 2, and that would take me to 33. The next one would be, and then 29, and then boom, done. So, how do you know you cannot type this one in the calculator? Because it has this f of n minus 1. An explicit rule would look something like this. F of n equals n something. There is no more f of something on this side, okay? You can't have that. So if you have that like you do here on both sides, that is called a recursive rule. You can't type that one in the calculator. You have to do it by hand here. So I want you to try number 11. Go ahead and do the same thing on number 11. Find the first 5 terms and then we'll check them. Okay, so you go back up here. The first term has a value of 45. So 1 is 45. What am I doing every time? I'm subtracting 4. So all I have to do is subtract 4. 45 minus 4 is 41. Now, if you can't do 41 minus 4 in your head, that's where you can use the calculator and type it in and get 37, 33, 29. All right, last thing, constructing and graphing sequences. Now, what I'm going to do as we go through this is I'm going to try to tie together how a recursive rule works with an explicit, okay? Explicit rules are very, very easy to graph. Very easy to graph, and I'm going to show you how we can do that. Now, example A is completely worked out, so I'm going to skip that one to example B. So, in example B, the first thing, and here we can use the calculator because I have an explicit rule. So the first thing I want you to do is go in your calculator to y equals and type in that equation, 20x plus 5. 20x plus 5. Okay, next, go to second window, your table set. You want your table to start here at 1. You want your triangle table or delta table to go by 1s because they're going up by 1s each time. Put them both on auto. And then go to second graph your table.
Wait, you said the table 1, table start?
At 1 because that's where this is at 1.
What is my calculator?
Now, if you look at the table, what is the value at 1? 25. What's the value at 2?
45.
45.
65.
65.
85.
85. 105. And 125. Those should be the values you put in. Okay, so there's a portion of this they did for you. They already gave you the equation. They are not going to do that as we keep moving forward. You have to come up with that. But you know that. You've already done this once with word problems. Read the problem itself. A movie rental club charges $20 a month. I could change that word "a" to what? $20 per month. And we said anytime we see the word per, we should think that is what? Our slope, our rate. It's our rate. That's how much we are paying. Plus a $5 membership fee. That is our starting fee. In this case, it's our what? Y-intercept. That's why you have to know all those different definitions for the words. So when we do y equals mx plus b, slope, rate of change, rise over run, change in y over change in x. Y-intercept, starting point, initial value, initial cost, zero term. Those are all terms, words you need to recognize and know. Now, in terms of plotting them, you don't have to do all this stuff in the middle. Your calculator has already given the values. Pay attention to the graph. Eventually, what's going to happen on these graphs, they're going to be completely blank and you come up with them. They have labeled them for you. X is number of months. You're charged $20 per month. The value of the function is how much they're charging in dollars. So for 1 month, it costs me $25. So I go to 1 and go to 25. Pay attention to their scale. Their scale, they went by 20s. Why did they go by 20s?
Because it went up. No, it was $20.
It's $20 per month. That was their slope, okay? Is this going to be a continuous or a discrete function?
Discrete.
This is discrete because you're not paying per day or per hour. You're paying per month. So there's 1 point. Then we go to 2 months, and now the cost is 45. So my points are not connected. It becomes a discrete function. Now, can everybody graph the points? Yes? Okay, so here's problem number 3. We're going back to the given rule. This is a recursive rule. It's recursive, again, because I have F on this side and an F on that side. So this is not an explicit rule that I can put in the calculator and it give me an answer. So how do I do this? Well, you can set up your table, and I'm going to show you, though, how to come up with an explicit rule for it. So when n is 1, I know the value is 65,536. Oops, I need to go back and erase that and make that a 1. What it wants is the first 4 terms. So I go to term 2. Now, how do I get term 2? I look right here. What am I doing to the previous term? I'm taking the square root of it. So here's what you do on your calculator. On your calculator, you type in square root of 65,536. Now, the square root button's on the left-hand side where the x squared button is. It's in blue, so that means you have to press second, okay? And you get 256. I need to get term 3. How do I get that? Now I do,
Square root of 256.
there you go, square root of 256. Square root is on the left-hand side where the x squared button is. It's above it in blue, so you have to press second x squared. What's the square root of 256? 16. So fourth term, what do? You take the square root of 16, which is 4. So real quick, let's look at problem 5. I'm not going to work it out. I just want you to tell me what you would do to the previous value. Here is our rule. So you're going to take the previous value and first do what? Right here, multiply by -4. After you multiply it by -4, then you are going to add 15. Once you get that value, to get the next value, what do? Same thing. You multiply that value by -4, and then you add 15. So here's what I want you to do. I want you to go ahead and finish 1 through 12 all. Do all of those. And then I want you to do 13 through 23 odd. 1 through 12 all. And then 13 through 23 odd.